It is indeed possible for an AM antenna to induce arcing in nearby metallic structures, a steel dome for example. AM antennas generate significant electromagnetic fields. These fields can induce electrical currents in conductive materials. When these induced currents encounter a high resistance, like at a joint or discontinuity within the metal structure, an electrical arc can occur. Besides the AM antenna, other factors might be responsible for the arcing. Firstly, inadequate electrical grounding can create a path of least resistance through unintended routes, including the arcing location. Secondly, loose electrical connections can also cause arcing due to increased resistance at the connection point. Thirdly, if the wiring is either improperly installed or has sustained damage, it can lead to shorts and arcing. Fourthly, corrosion can increase resistance and contribute to arcing, particularly in joints and connections. Fifthly, transient voltage surges, which are sudden spikes in voltage, can overwhelm the insulation capacity of the system and initiate arcing. The Federal Communications Commission, or FCC, does not impose explicit height or distance restrictions regarding AM antennas. However, AM antenna manufacturers usually provide recommendations for minimum distances from buildings and other structures. These recommendations aim to minimize potential electromagnetic interference and ensure the antenna's safe operation. To establish whether the AM antenna is the actual cause of the arcing, a systematic investigation is advisable. Firstly, meticulously inspect the antenna's proximity to the dome steel structure. Identify any points where contact or near contact is possible. Secondly, check the electrical grounding system associated with both the antenna and the steel dome. Ensure that the grounding is robust and meets the required standards. Thirdly, use appropriate equipment to measure the electromagnetic field intensity in the vicinity of the antenna and the dome. Elevated field strengths might indicate a greater risk of induced currents. Fourthly, consult with an electrical engineer or an antenna specialist for a thorough assessment and recommendations. Their expertise can help pinpoint the cause and recommend appropriate solutions. If the AM antenna is confirmed to be the source of the arcing, several mitigation measures can be considered. Firstly, reposition the antenna to increase the distance between it and the steel dome. This reduces the intensity of the electromagnetic field affecting the dome. Secondly, consider installing a shielded enclosure around the steel dome. The shielding minimizes electromagnetic interference from the AM antenna. Thirdly, upgrade the electrical grounding system to provide a more effective path for unwanted currents. Fourthly, inspect and tighten all electrical connections to minimize resistance and potential arcing points. It is crucial to remember that simply having an AM antenna nearby does not automatically implicate it as the cause of arcing. A comprehensive investigation is essential to pinpoint the actual underlying reason. AM antennas are generally safe and do not represent significant health or safety threats when properly installed and operated.